Okay, welcome to Chapter 9, Section 2, and we're going to generalize the square root property. So these questions are solved very similar to the square root property. So we're going to work through them in the exact same way that we would other questions in Section 2. So taking a look at this first question, the first thing that you notice is that the cube root will not undo a difference. So take a look at that left side and you can see that it's a difference. According to the order of operations, the last thing that we do is subtraction. So therefore, we need to undo that subtraction first. So we need to add 18 to both sides. We're working backwards to the order of operations. We're undoing as we go. And the moment we've done that, we've got the cube by itself on the left side. Why is that good? That's good because a cube root will undo a cube. So we take the cube root of both sides. Now, you're going to see this topic again in pre-calculus, and you're going to see all three solutions. We're not going to be able to find all three solutions with the kind of just generalizing the methods of beginning algebra. We're only going to be able to find one of them. But it is one of them. We will be able to find one of those solutions. Now, when you look at this, you can see exactly how nice it is. On the left side, the cube and the cube root are going to undo each other. And on the right side, we've got a perfect cube. That's 7 cubes, so out pops a 7. So nice way of making this work. We're going to be able to find one of those three solutions. We're going to add 9 to both sides. And there's one of our solutions, x equals 16. That's all we'll be able to find in Math 120 and intermediate algebra. But remind yourself that there are 2 more and that you'll be able to find them in pre-calculus. Now, when you check this, you simply substitute in that 16 for x. 16 minus 9 is 7. 7 cubed is 343. 343 minus 18 is 325. So that equals that right side there. Now, as we're working through this process of undoing exponents, we see that we can even undo fractional exponents. You can think of that exponent exactly the way that it is. It's a fraction. And if your goal is to make that exponent into 1, then you ask yourself, what do you have to multiply a fraction by to make it equal to 1? And of course the answer is the reciprocal. The reciprocal of 4/5 is 5/4. And when you multiply 4/5 times 5/4, the 4 cancels and the 5's cancel. So we need to raise both sides to the 5/4 power. So we're going to do exactly that. So in the next step, we raise both sides to the 5/4 power. Now you can do the right side. It's entirely arithmetic in your calculator. Just make sure that that division happens in the exponent. The other way that you can do this is you can take the 4th root of 16, and the 4th root of 16 is 2. Remember that a denominator in the exponent is the index. That's why I'm saying the 4th root of 16. That's 2. And then 2 to the 5th power, well, 2, 4, 8, 16, 32. That right side is 32. You can do it in your head or you can do it with a calculator. The left side's even easier. The 5's cancel, the 4's cancel, and we're left with nothing more nor less than 3x minus 2. Now that's equal to 32 on the other side. We're going to find one of the solutions, and that's good enough for Math 120. We now want to get the x by itself. We're working backwards through the order of operations. The last thing that the order of operations say happen on the left side is that subtraction. So we're going to undo that with addition. We're going to add 2 to both sides. That's going to give us 32 plus 2 equals 34. Then, of course, the last thing we have to do to get the x by itself is to divide both sides by 3. 34/3 is another name for 11 1/3. And if you plug that in, it checks out fine. Now, these last 2 examples are interesting because we will be able to find all the solutions. So here in Math 120 and Intermediate Algebra, we can solve these equations. Now, remembering back to beginning algebra, when you saw questions like this before, your answer was supposed to be no real solution. So we were supposed to say, essentially, we cannot find a number that makes this work. But notice that we now have imaginary numbers, and so we can make this work. Okay, so we're going to do exactly what we did in beginning algebra. We're going to work backwards through the order of operations. The last thing that the order of operations say to do to this is to add 9. So we're going to undo that by subtracting 9. And of course, in Math 100, in beginning algebra, you were supposed to look at this and say, you can't square anything and get a negative number. Negative numbers squared are positive. Positive numbers squared are positive, and 0 squared is 0. But we've got imaginary numbers now, so it's perfectly fine for us to go the next step and take the square root of both sides. Remember, we're generalizing the square root property, and these last two examples are perfect ways of illustrating that. So we're going to take the square root of both sides. What's the price we have to pay when we take an even root? That's right, the plus or minus sign, and there it is. We're taking the square root of both sides. We're not forgetting the plus or minus sign. That's how we're going to get all of the solutions. And then we simply simplify this. On the left side, the square and the square root undo each other. That leaves us with an x. And on the right side, we've got the plus or minus sign. The square root of 9 is 3. The square root of negative 1 is I. So our answers, plural, are 3i and negative 3i. And there they are. So another very similar example, x squared plus 25 equals 0. We're going to work through it in exactly the same way. We're going to undo the what was done to it, working backwards through the order of operations. So no great surprise, I'm going to undo the last thing the order of operations tells us to do. It says to square and then add, so I'm going to undo that addition by subtracting 25 from both sides. So we've got x squared equals negative 25. Back in beginning algebra, you were supposed to say no real solution. Now we say, hey, we can take the square root of a negative. Just as long as we don't forget the plus or minus sign, the square root property still applies. And of course, the square root of negative 1 is I, and the square root of 25 is 5. So there's our two solutions, 5i and negative 5i. Pretty cool, huh?